Special thanks to all of my Patreon supporters. If you want to support this channel, please do check out the link in the description below. And now let's get back to the video. Hello everyone, welcome back to my channel. Today I just wake up in the morning today and it seems like something huge is happening right now in AI. And let me show you what happened. So apparently Meta AI just released Llama 3.2. And it's apparently a vision language model, right? And it's open source. And the thing about it is that I don't expect Llama 3.2 to release so fast. Like a couple of weeks ago, we just have Llama 3.1, and it's pretty much the state of the art in open source LLMs. But let's see what they have to offer right now in this case, right? So what what we are looking at here is essentially the Meta website, right? So this article is launched yesterday, I believe. So let's have a look into it, right? So it's Llama 3.2 revolutionizing edge AI and vision with open customizable models. So I bet there's gonna be a huge emphasis on like smaller LLMs. I believe, right? So let's have a look at this. Okay, so all right, just from this picture here, I'm seeing two on-device models, and they offer 1 billion and 3 billion. I bet those are the lightweight models, and the other one is the multimodal models. Okay, so they offer us 11 billion and 90 billion. Okay, wait a minute here. Okay, so I will have to guess that the on-device models would not be a multimodal model, right? It's just gonna be a standard LLM, I think. As for the multimodal model, why is it just up to 90 billion? How about the 405 billion parameter model? How about that? But hey, I'm not complaining here. It's good that they release these things for us. But anyway, okay, let's take a look at what they're saying here. Okay, so they're releasing Llama 3.2, which includes small and medium-sized vision LLMs, 11 billion and 90 billion. They call these medium-sized, but I can even barely fit it into my own GPU. Yep. And they have the 1 billion and the 3 billion parameter text-only LLM models that can be fed into edge and mobile devices, like a freaking smartphone here, I believe, right? Especially when you convert it into a format called GGUF, right? And then you can use Llama C++ to run it, then that should be fine. Okay, and they are providing a pre-trained model and an instruction to model here. Okay, I wonder if they release like any kind of paper, right? But I haven't found one so far. Yeah. So the 1 billion and 3 billion parameter models support context length of 128,000 tokens. I mean, that's fair, right? Okay, and it's state of the art in for on-device use cases. Okay, so it's pretty good at summarization, instruction following, rewriting tasks. All right. And these models are enabled on day one for Qualcomm and MediaTek hardware and optimized for ARM processors. Okay. Right. Okay, how about the 11 billion and 90 billion parameter vision models are drop-in replacements. Sorry about that. Accidentally did that. Okay, are drop-in replacements for their corresponding text model equivalents, while exceeding on image understanding tasks compared to closed models like Claude 3 Haiku. Oh, okay, interesting. Right. Unlike other open models, both pre-trained and aligned models are available to be fine-tuned for custom applications using torchtune, then and deployed locally using torchchat. Okay. I never heard about torchtune here. So let me check that out. Okay. So what is this here? Okay. So it's under PyTorch. Where is it made? Okay, it's made like a year ago, is it? Yeah, about that. So Torch 2. Okay, right. So Torch 2 is a package that allows you to, okay, right, fine tune and experiment with LLMs, and it has all these different RL techniques right here, the DPO, PPO, and some low rank adaptation methods here, plus knowledge distillation. That's pretty cool. Okay, right, and that's that. How about and deployed locally using torchchat? I wonder what this is either. Okay, let's see right here. Chat with LLMs everywhere. So it's a small code base showcasing the ability to run LLMs. With that, you can run LLMs using Python within your C++ application and iOS or Android. Okay, right. So it's just purely for deployment. Okay, that's fine. Yeah, not that interesting to me, but okay. Okay, they are also available to try using our smart assistant Meta AI. Okay, here's the problem, right? I tried going in here, but just have a look. God damn it. God damn it. Yep. Can't use it. Apparently, right? I know. But I would probably download it from Hugging Face and give it a try. Probably the tree billion parameter model. Damn it. Okay. Okay. So they're sharing the first official Llama stack distributions. Okay. Right. So the Llama stack, from what I recall from other YouTube videos about this, is that it is some kind of a package stuff. Right. Let's see how. Okay. Right. So this is the Llama stack API. Okay. So it's these things right here. So you can run AI agents in production, APIs, blah, blah, blah. Okay, that's that. Right, so basically, if you guys want to use this stuff, go right ahead, right? But I'm not gonna be doing that during my free time. But unless you have some kind of a business that you want to use this, then go right ahead. I think that's a pretty good option here. Wait a minute. Where am I? Okay, right. Llama Stack, which greatly simplified the way developers work with Llama models in different environments, including single node, on on-prem, cloud, and on device. Is it raining? Oh yes, it is. Sorry about that. Enabling turnkey development. Deployment with retrieval augmented generation and tool enable applications. Okay. So, okay, I guess what you're saying here is that, oh yeah, if you want to use the Llama models, you can do it on either on AWS, Databricks, Dell, Fireworks, and so on. All right. On-device distribution is through PyTorch executorch. Okay, executorch. What is this? Okay, executorch is an end-to-end solution for enabling on-device inference capabilities for mobile and edge devices, including wearables. Yeah. Speaking about this, right? Yeah, I bet there's a correlation here. You see, there, right? Hey, imagine the AI, right? Integrating Llama 3.2 into these Ray-Ban glasses, right? I bet that's the endpoint of their innovation here. I mean, an instrumental goal, perhaps. So yeah, and I bet that's the only reason why they are even doing like all of these like smaller versions of the LLMs is so that they can sell their products that uses these like edge compatible LLMs. Okay, so okay, right. And single node distribution is via Llama. Okay, blah blah, and then some fluff right there. We don't need that. Okay, so right now you can download it on llama.com or Hugging Face. Actually, I'm wondering how does it look like on their website. Just a second. Always hydrate yourself. Right. Hmm. That's pretty good. All right. Wait a minute. Wait. Okay, right. So that's the website right there. Yeah. Obviously, if you want to download it, you have to like submit a form, I believe, right? So here's the Hugging Face website, and as you can see, right, you can download it on Hugging Face. The only issue might be that you need to sign up or log in, and you need to like fill in this long page of a form, and then yeah, and depending on the context, right, it could either accept you, it could either allow you, or they could just blatantly reject you from getting it. So yeah, so that's quite an annoyance there. Okay, right. So blah blah blah, and they have some fluff right there. Okay, blah 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 blah. Okay, okay, right, right. That's not really that important. Okay, so this Llama 3.2, I think it's announced during their latest event at Connect, I believe. So Meta Connect, Meta Connect, Meta AR. Yeah, exactly. So essentially, there's a meta event going on like a day or two ago, I believe, where they showcase their newest works and their newest products. Though I'm not so sure what products they're doing exactly here because I'm not that interested in it. But yeah, so that's that. Okay, and then pretty much repeat the same thing, like what they have done, blah blah blah. Okay, so essentially all this fluff just talks about how great they are in doing these things, how thankful we should be towards them. Okay, all right. So right. Okay, so for you guys who's in Europe, unfortunately, you're not gonna be able to get the model unless you go through some right. So I believe if yeah, so I saw a Reddit post that apparently European users can't download the models unless you use some kind of a VPN, then maybe you can. But I guess that's just policies and then like trying to not get like in trouble for Meta. But anyway, that's not really important for us right now because let's see. Okay, so right here, they say, okay, so right in this passage here, they say that, okay, one of the use case for their multimodal model is that you could ask a question about which month in the previous year their small business had the best sales, and the model can reason based on an available image graph and provide the answer. Okay, so basically the entire passage that just describes about how well it can reason using the image data. So, and it can extract information from the image, much like other vision models. Mhm. So yeah, I wouldn't say there's much innovation, especially when we have like other open source vision language models already. But yeah, but if they can outbeat their competition in this case, then it would be cool. And I bet they will, but we shall see soon. Okay, right. And they say that their lightweight models are pretty good in multilingual text generation and tool calling abilities. Okay, cool, cool. Tool calling abilities, huh? So, so yeah. So as for tool calling abilities, devices like the Rabbit R1 would probably use this sort of things, right? But at that time it is just not as good, right? But I really didn't know. I mean, I'm just imagining stuff up right now, but essentially, right, you can integrate these small models into your Apple or Android phone, and then you can be like, hi AI, can you pick up the call or make a call or maybe take a picture or something, right? So that's a possible application of it, I guess. Okay, so let's see. Right, running these models locally comes with two advantages. Firstly, the prompts and response is done very quickly. Okay, you say that, okay, right. The prompts and response can feel instantaneous. Well, it depends, really. It depends. Like, it depends on what kind of hardware you're using. I bet something like a Raspberry Pi wouldn't be that quick, right? But, okay. And secondly is privacy here. Okay, right. Don't really care about that. Okay, next. Model evaluations. So they evaluated that their newest vision models are competitive with Claude 3 Haiku and GPT-4o Mini on image recognition and a whole range of other vision tasks. Okay, why not compare it with like even larger ones? You know, I'm just saying here, but man, comparing it to GPT-4 Mini, that's not really saying much, honestly. Okay, next. The 3 billion parameter model outperforms Gemma to Gemma to 2.6 billion and Phi 3.5 mini. And I think how large is the mini model? How many parameters does it have? I think it has like it is close to like 4 billion parameters for the Phi 3.5 for the Phi 3.5 mini, right? So I think that's a fair comparison, and I will even say that if this 3 billion parameter model outperforms this, that's already pretty good actually. So, okay, let's take a look at the benchmark here. Okay, right, and they evaluated the performance over 150 benchmark data sets. Okay, that's crazy. That's crazy. That is crazy. Right, let's have a look into it, shall we? I'm excited now. So benchmark image and text benchmarks. and I bet they only show like a few of them. So vision instruction to benchmarks. Okay, got it. So MMMU, right? So these are college level problems and mathematical reasoning problems. Okay, so MMMU. Okay, let's see. MMMU benchmark. MMMU benchmark is something. Wait, hold on. Okay, right. A massive. Okay, right. Massive multiple discipline, multimodal understanding and reasoning. Okay, right. So it is like every single subject, right? And then it's like asking questions from every single subject imaginable. Yeah, that's the kind of benchmark, I suppose. Okay, right. So that's that. And pro, I'm gonna assume that pro means even more difficult, judging by how the accuracy drops instantly. And then this one is the vision version of that. Okay. So and Math Vista, no idea what's that, but I'm not gonna search that up. So let's see. Okay. And there's some chart Q&A, AI to diagram, doc visual question answering, vision question answering, V2, MMLU, math, GBQA, MGSM. Okay, right. So let's have a look into that. All right, and one thing to note is that yeah, there's no values for GPT-4 or mini for these four different benchmarks, right? But anyway, let's compare it now, shall we? So right here, okay, so when they scale up the model, all right, it improves in this part, the MMMU, that goes the same for pretty much all of them, I think. So 91% to 92%, 88 to 90%, all right, right. So the improvement is consistent here, which is nice to see, which means the scaling works in this case. Um, do we know much about the parameter size of these two models? I don't think so. But just judging solely from the numbers, right? It seems like 90 billion parameters is really like beating a lot of them, except for this one and this one right here, this M MGSM, right? So obviously it would be nice to know how large this model is, but obviously because it's open AI, we get to know uh, close to nothing in this case. Right, but I'm more interested in this one right here, the lightweight instruction tube benchmarks, because it's the only kind of LLM that I can use. Oh dear. Okay, let's read. All right. And what I'm hoping here is that this one truly outperforms every one of them, right? Yeah. I mean, if it can already outperform this, then it's totally enough for me, right? But let's see. Okay, 1 billion versus 3 billion. Let's see how much it improves. Aha, we found like, okay, so it doesn't improve here. Instead, it decreases in accuracy. Interesting. Okay, so open rewrite eval. Okay. Then next, what do we have? Okay, so it consistently improves. I can see that. So from 41 to 69, nice. For Hella Swag, and this one right here, Infinite Bench, ENQA, right? The accuracy drops from 20% to 19%. Okay, right, interesting. Okay, right. So aside from the two anomalies, everything looks okay. But now the real part comes in. Okay, so for MMLU, Phi 3.5 outperformed the 3 billion model, right? And what else more does it outperform it? Okay, and for GSM 8K, it outperforms the 3 billion parameter model. So yeah, it has 86%, while this one has 77%. Okay, right. So in total, Phi 3.5 won about like one, okay, one, two, three, four, and five. Okay, so it won 5 tasks. Well, how much this one won? Let's see right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right. So it's yeah. So it's essentially 10 versus 5. Okay. Right. So that's around how many percent, I believe. Right. So that's like so how many percent? Okay. Right. So it's 67%. Okay. I mean, technically, right. 67% sounds okay. Um, You know what? Okay, just because the 3 billion parameter model is smaller than Phi 3.5, which happens to be 3.8 billion parameters, right? Okay, you know what? I will take it. You know, I will take it. Uh, but still, I think the performance could be a lot more better. I think. But if only they have like a paper or a technical report about it, maybe I can find out what they did to make it better than Phi 3.5. Okay, now there's some technical details here, and this is the kind of thing that I really like, but it seems like it's not really that in detail. Okay, right, there's some details here. Okay, so let's go through it, shall we? Okay, so right, and they say that, oh yeah, this is the first time that the Llama models can support vision capabilities, right? And it requires a new model architecture. So essentially, what they did here is that okay, they train an adapter network, right? A set of adapter networks, I believe, right? So essentially, it is kind of like in the other videos, which are talk about the vision language models, right? So there's a lot of ways to like make a VLM, right? Either through things like directly inputting the image into the input layer, or you do some kind of a cross attention for each attention layer, right? Right, and you perform cross attention with the image input as well. But let's see what they did here. So they use adapters, right, to integrate a pre-trained image encoder into a pre-trained LLM. In this case, that would be the Llama model. Okay, and to say the adapter has a set of cross-attention layers that feed image encoder representations into the LLMs, and they train the adapter on text image pairs to align the representations between the language representations, right? So during adapter training, they updated the parameters of the image encoder, but intentionally not to update the language model parameters. By doing so, we can keep all the text-only capabilities intact, right? Yeah, and this whole set of ideas, this whole set of methods isn't that new, honestly. Though, like I've already seen like a lot of papers doing the exact same thing, right? So let's go through it. Okay, so essentially, they start off with the pre-trained Llama 3.1 text models, right? And I bet all of the text models except for 405 billion parameter model, which is their state-of-the-art largest Llama model. Okay, so okay, the first add image adapters and encoders and pre-train on large-scale noisy image text pair data, and then they train it on medium scale high quality in domain and knowledge enhanced image text pair data. Okay, so essentially, right, so essentially there's a recent paradigm that tells us that, oh yeah, it would be much more beneficial give if you train the AI model on like a crap ton of bad data, right? So essentially, there's going to be a huge amount of it, right? But it's not going to be like any sort of like gourmet kind of quality here. But as the training progresses step by step, you quickly feed in a bit and a bit of those high quality data into it. And that's exactly what they are saying here. Um, yeah, the only thing I'm not so sure about this part right here, this a large scale noisy pair, is that are you purposely feeding in the noise, or the noise has already been present in the data set? I'm not too sure about that in this case, but it could be either way, right? So, okay, in post training, they use a similar recipe as the text models by using several rounds of alignment on supervised fine tuning, SFT, rejection sampling, and DPO, direct preference optimization, which is an RL algorithm, right? So, and they use synthetic data generation to filter and augment question and answers on top of in-domain images, and use a reward model to rank all the candidate answers to provide high quality fine-tuning data. Okay, so imagine what OpenAI o1 model did, right? But scale it back down a bit, right? Hmm. Yeah, so I don't think there's going to be anything fancy here, like a chain of thought, chain of thought plus RL. No, this is just our like typical VLM um, model here, right? So okay, the end result is a set of models that can take in both image and text, blah blah blah. So they have a GIF image here. I know people call it GIF or whatever. I'm calling it GIF because it's GIF, right? But how about giraffe? Okay, I'm not gonna say anything else about that. Okay, so obviously, if you put it an image, it's gonna talk about the image. Okay, suggest alternatives. Okay, so essentially it generates a bunch of descriptions. Wait, hold on. What is happening here? Wait. Okay, right. You put in an image in there, okay, and it analyzes the image, right, and it produces a description about it. Okay, it detects. It has object detection in there, and then okay. Is it? Wait a minute. Right, so it's going through the internet to like find the object. Okay, right. What's the use of that? Honestly though, isn't that something like you can do on like Google Image already? Okay, right. Lightweight models. Okay, right. Powerful teacher models can be used to create smaller models using pruning and knowledge distillation, right? For those of you who do not know what pruning is basically finding like, how in like typical neural networks, there's a lot of weights, right? So essentially, you you cut one of them out in order to save compute time and memory. And for distillation, it's basically just having like a really good large model, right? And then you let the smaller model learn from it, right? And typically using that would give you like a lot of accuracy in the process. And that's how they create their lightweight models. In this case right here, I think. Yeah. Okay. Right. And then mentioned here. Okay. Systematically removing parts. Okay. Systematically removing parts of the network and adjusting the magnitude of the weights and gradients to create a smaller, more efficient model. Yeah. That's that. Yep, like I said before, knowledge distillation uses larger network to impart knowledge to I would say it like transfer knowledge from a large network to a small network. Okay, so for the small models, they incorporate logics from the 8B and 70B models, right, during the pre-training stage, right, where the outputs or logics from the large models were used as the token level targets. So essentially, you ask it to mimic the output by specifying in the loss function there. And there's like a couple of ways to do it, which I already discussed about this, I believe, in the previous couple of videos about knowledge distillation for graph neural networks, but it's essentially all the same ideas, right? If you want to check it out, go and do that later. But yeah, so here they have a pretty diagram here. Pre-training data mix. Okay, so this dark color is collected data, derived data, pre-trained model, and instruct model. Okay, right. Let me see. Pre-trained data makes. Okay, so Llama 8B pre-trained, Llama 17B pre-trained, and then logic combine all their logic data, and then somehow use it to fine tune it and prune them out. And then okay, on the other side, there's a need to have like okay, synthetic data prompts and generate synthetic data prompts using the most expensive model, which is their 45B instruct model, and then use it to create the prompts and in order to create synthetic data and then combine the synthetic data with the fine-tuning data in order to fine-tune this pre-trained model here. Okay, right. So that's pretty cool. Okay, so let me see. Okay, so okay, and each round of alignment has SFT, RS, and DPO. Right. So in post training, so after the main training process, the scale the context length to 128K tokens. Right. Okay, right. And then talk about how they work closely with Qualcomm and MediaTek to do those edge device stuff. So the weights being released today are B-Fluid 616. So, and they promise that they will try out different quanti variants that will run faster and they will share more results in the future. Okay, that is really cool. And here's an example of it. Okay, conversation input, inference, and summary, extract action items tool called, which is exactly what we should have on the smartphone, right? Yeah. That's pretty cool. Right. Okay, this is a figure right here, and then apparently just like tell it to like rewrite stuff. Is it? Okay, so this demo is based on an unreleased quantized model. All right, so this is just an example here. Okay, wait. This is the benchmark. Oh, sorry, man. Okay, right. Wait a minute here. Why is the 1 billion better than a 3 billion one? In this case, why? That is so strange. Okay, why is that happening? I apologize for the convenience. Blah, blah. Okay, how's that any different from Chat GPT? Okay, and they talk about their law stack distribution, blah 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 blah. Yeah, and there's a lot of stuff in their APIs, their collection of APIs here and there, agentic apps, agentic system API, and then there's a lot of APIs here and there, but that's not the main focus of today's video, right? The full release includes Llama command line interface, client code, Docker, and other sort of like distribution stuff right here. Okay, so there's a lot of stuff here, and okay, right. And here's something special again: system level safety. Let me see. Okay, so is it like guardrails in this case? Okay, they released Llama Guard 3 11B Vision, which is designed to support Llama 3.2's new image capability. Okay, wait, hold on a second. Guards against concentrating power in small hands of a small few and deploys technology more safely across society. Okay, no, okay, right. So basically democratizing everything, but I don't get it about this one here. Okay, as we release those models in more constrained environment, we optimize Llama to drastically reduce its deployment cost. Okay, right. So are you telling me that Llama Guard is essentially okay? Right, I see it now. So Llama Guard is essentially a more optimized version of the already small models. So essentially, if you use Llama Guard, you could possibly use it in the Raspberry Pi because it's like only less than like 500 MB compared to almost 3000 MB, which is 3 GB essentially. Okay, I get it now. So essentially, I can like buy a lot of Raspberry Pis, and then each one of them can be an agent, and then yeah, and then essentially I can have a, a robot army in this case. Am I right? Okay, so okay, right. So the model is available, and yeah. So feel free to try them out, obviously. But okay, right. I'm showing the wrong thing. Yep, it's supposed to be this one right here. Yep. So feel free to try it out, right? If you are in the United States, then you can probably try them out in their official website. Otherwise, like myself, I have to download the damn models here, right? So obviously, I have to like fill in a lot of things here, country, blah blah blah, right? So yeah. So you can essentially select anything that you want, right? Yeah. Okay. Yeah. I Okay, let's see right here. Okay, so they can do that. That's pretty Cool. Yeah. Okay, but since that's right. Okay, right. And there's some issues with it. I suppose with every single like new release, there's gonna be a few bugs here and there, but I think it's going to be fixed soon. Yeah. Okay, guys. Yeah. I guess that's it for this video. Yeah. So if you like what you see, please do make sure to like and subscribe, and do check out my Patreon. Link is in the description below, right? And and this isn't my usual video, my usual type of video, because I mainly cover papers, which I typically like more than covering like a blog post here. But since I couldn't find any technical papers about it. So yeah, it's kind of like informal in this way. Well, yeah, but I can't really complain, you know. Okay, right, yeah. So yeah, and do check out my Patreon if you want to support this channel. Link is in the description below, and I will see you guys in the next video, which I will talk about a paper for real, right? Yeah, bye.